In this video, we are going to see how to show whether a vector field function is conservative or not using curl. Now to find out the curl, what we do is we cross product the del operator with vector field function, and when we find the curl, if the curl is equal to 0, this is a conservative vector field. If it's not equal to 0, it means this vector field function is not conservative. Now in order to do the cross product, what we have to do is we have to put it in a matrix form. Here we are going to have I, j, k, and after that we put the del operator. That's going to be partial derivative with respect to x, partial derivative with respect to y, and then partial derivative with respect to z. And we are going to pick up pqr. In our case, like pqr is our x, y, like here you can see I, j, k component. I is the value for I component, that's going to be our p function, right? And the q function is going to be the j component, and the r function is going to be the k component. In our case, this is going to be our p, this is going to be our q, and this is going to be our r. Now we are going to put it in a matrix form in order to do the cross product. Here we are going to have I, j, k, and after that we put the del operator, that is partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z, and after that we copy this pqr functions. P is 2x plus yz, and then q is xz, and then r is yx. Okay, now cross product is same as determinant. Like if you remember, we put plus minus plus, and after that we, if we pick I, we eliminate the whole x and y, like not xy, vertical and horizontal component that is related to this one, and we are left with this part. Now for this one we do the AD minus BC. If we think like A, B, C, D, we do the AD minus BC. That's how we do the cross product. Okay, now here we are going to do for this one. Here if you find AD, this is going to be partial derivative of this yx respect to y. If you find that one, that's going to be x, because derivative of y is going to be 1. When we take the partial derivative with respect to y, we treat x as a constant, so this is going to be just x. And when we do the minus, when we do the opposite part, bc, this is going to be partial derivative of xz respect to z. Since z is going to become 1, because we are taking the derivative with respect to z, z is going to become 1, so we are going to have x alone, so this is going to be just x. And after that we put minus, let's say this curl is equal to x minus x, and this is our I component. And after that, when we pick up this j component, we eliminate this part, we eliminate this one and this one, and this is the only thing that's going to remain. Now we are going to do the AD minus BC. When we do that, we are going to take the partial derivative of this yx with respect to x. When we do that, we are going to get y here. Okay, and when we do the opposite side, we are going to take the partial derivative of this 2x plus yz with respect to z. When we do that, this 2x is going to become 0, because this is a constant, right? So when we take the derivative of a constant, that's going to be 0. And here we are going to take the yz respect to z. Z is going to become 1 and y will remain, so this is going to be just y, and this is our j component. And after that we are going to do for k component. When we do that, we eliminate this part, we eliminate this part right here, and we do the AD minus BC for this one. Now let's copy our q component, that's erased, xc. Okay, now we are going to do the AD minus BC for this one. Here we are going to have, okay, when we do the AD, this is going to be partial derivative of xz with respect to x. When we do that, we are going to have z here, and then if we do the partial derivative of this one, this 2x plus yz with respect to y, that's going to become, this 2x is going to become 0, because this is a constant, so this is going to become 0, and here this y will become 1, then we are going to have z alone, and this is our k component. And from here we can see this is going to be 0i minus 0j plus 0k. We are having 0 0 0, so this is going to be 0, curl is equal to 0. If the curl is 0, this vector field function is conservative. If it's not equal to 0, this is not conservative. So here this is 0, so we can say therefore this vector field is conservative. And that's going to be our final answer. I hope this helps. Thanks for watching.